All right, we're going to now look at just multiplying radicals. Okay. All right, so when we do this, I just want to kind of get you to think about something different than what's on the sheet for just a minute. Sometimes you're going to have to do something like this. You're going to have to take something like 2 square root of 5 and multiply it by 7 square root of 3. Okay. And when you're multiplying, it's possible to do that, even though the radicals are different, because these are just multiplications in between here as well. Okay. And so you really just have 2 times 7 times square root of 5 times square root of 3. It's okay to rearrange since it's all multiplying. And then these numbers that were in front of the radical, that were outside the radical already, can be multiplied. And then the two numbers you see inside the radical can be put back together underneath the radical. Okay. So do you notice how the outsides stay together? Okay. That's the outsides. And then the insides have to or can stay together. So when you multiply things like that, you can multiply the outsides and you can multiply the insides. But the outsides stay with outsides and the insides stay with insides, okay? All right, so here's a couple multiplying problems, and that issue right there is going to be an issue on some of them, but the number 18 is a little simpler. Okay, so on 18, we have two binomials that we're going to try to multiply. So one of them is square root of 7 minus 5, and one of them is square root of 2 minus 5, okay? So first, we're going to use what we did back with multiplying polynomials. We're going to FOIL. We're going to multiply the square root of 7 throughout, distribute it throughout, and then come back in and distribute the negative 5 throughout. So when we do that, we're going to take this step right here. Ultimately, I want you not writing, but I'm going to show it to you here. Square root of 7 times square root of 2. Then this is a positive times a negative, so it'll be negative. 5 is an outside. Square root of 7 is an inside. Okay. Then we're going to go to here. Negative times a positive is a negative. 5 with a square root of 2. And then the last one is a negative times a negative, which is a positive, and it'll be positive 25. And then the square root of 7 and the square root of 2, they're both inside, so they can be put back together underneath. But then these are not like radicals, so you can't combine them because they don't have exactly the same radical part. And so it turns out you get 4 terms, okay? All right, but sometimes you'll have a problem like, what if it were, we had something like square root of 7 minus 5 times square root of 7, and maybe we even could have a number on these. Let's put a number on here to make it a little more interesting. Maybe we could have 2 square root of 7 minus 5 and 3 square root of 7 plus 2. Let's see what happens there. Okay, what happens is kind of similar. Move that up. What happens here is kind of similar to what happens when you're multiplying polynomials. We're going to wind up having middle term that can be combined. Middle terms that can be combined. So the 2 square root of 7 gets multiplied by the 3 square root of 7. They were both positive. Then a positive times a positive would be positive 2 square root of 7 times the 2. A negative times a positive would be negative 5 times 3 square root of 7. Then a negative times a positive would be a negative 10. Okay. All right, and then this step right here is the step I really want you to not write, but this is the first time you've seen it, so I wanted you to at least see it. What I really want you to do is be able to look at 2 square root of 7 and 3 square root of 7 and say, okay, let me multiply the outsides together. Now let me multiply the insides together. Okay, and then here, 2 square root of 7 times 2, these are both outsides, so that'd be 4 square root of 7. Here, the 5 and the 3, they're both outside, so that'd be minus 15 square root of 7. And then at the end, we have a negative 10. So if you notice this time, these two terms in the middle are like terms, so we're going to be able to combine them, and we're going to get a negative 11 square root of 7. And then the 6 here, and this square root of 49, see that square root of 49, that's 7. And so we really just have 6 times 7, which is 42. And so we have one more step, the 42 minus the 10, that's going to wind up being just 32 minus 11 square root of 7. Okay. So the difference between those two is on this one, see how it didn't really have the same form? We had square root of 7, but here square root of 2. That's why things didn't wind up having middle terms that would cancel out. Okay. All right, so I want you to not write this. I think it gets too messy. So not write this. Okay, so try to get to where you don't have to write that. That you just look at these two and you think outsides times outsides. Okay, they have to stay with the outsides. And then insides times insides. Okay, so the outsides get multiplied together and then the insides get multiplied together. These were both outsides. These were both outsides. Okay, and so you'll do this will be the first thing you write, and then you just simplify from there. Okay. All right. Now let's look at number 19 on the worksheet. With problem number 19, you had it written with parentheses. So you had 3 minus a 5 square root of 2, and all of that was going to be squared. Well, it's really important when you see that 3 minus 5 square root of 2 is really being multiplied by itself. So you have that same thing twice. Okay. All right. So what we're going to do now is do the foiling idea. So we're going to do 3 times 3, get 9. Then we're going to do a positive times a negative, which is negative. And then 3 times 5 square root of 2, this is an outside, this is an outside. So that would be minus 15. All right, then we're going to come back here and we're going to say, okay, here we have a negative times a positive, which is negative. 5 times 3, they're both outside, so they go together. And then you just have the square root of 2 on that. Then at the end, we have a negative times a negative, which becomes positive. 5 times 5 is outside. Square root of 2 times square root of 2, the 2's are inside, so you can put them back together underneath that radical. All right, so you wind up with, let's see if I can get that back up where it was. Let me just rewrite that up where it was supposed to be. I touched it. Okay, all right, so this turns out to be plus, we said 25 square root of 4, okay? All right, so what's going to happen is these are like radicals. So negative 15 square root of 2, negative 15 square root of 2 would be minus 30 of them. And then we also can take that square root of 4 and do that. That would be 2. So we have 25 times 2, which is plus 50. So we have 59 minus 30 square root of 2. All right, now don't be tempted to say 29 here. This doesn't have the radical part on it. Just like if it were 59 minus 30x, this should be your final answer, right? So don't wind up going any further. You would stop right here, okay? It's not 29 square root of 2 because that doesn't have a square root of 2 on it, okay? All right, now let's do one variation of that kind of sets us up for something we're going to use in the next problem. What if it had been a 3 minus a 5 square root of 2, but then over here a 3 plus a 5 square root of 2? Let's see what would have happened then. You'd had your 3 times 3 and get 9. 3 times the 5 square root of 2, the 3 and the 5 are outsides. The negative square root of 2 times the 3 would be a negative 15 square root of 2. And then the negative 5 square root of 2 and the positive 5 square root of 2 would be negative 25 square root of 4. Okay, these are like terms. So that would be 9 minus 25 square root of 4. Okay, at that point. And then we have to look here and notice the 4 is a perfect square. So that becomes 2. and we have 9 minus 25 times 2, 9 minus 50, we wind up with negative 41, period, as our answer to that. And see how all the radical stuff is gone? Okay, that's going to be something we're going to make use of in the next video. So this is the end of the multiplying video. All right, so I'm going to stop.